In December 2020, China's Chang'e 5 mission returned lunar samples containing mineral structures that should not exist. The crystalline formations show isotope ratios inconsistent with natural lunar geology and match precisely the signatures of controlled nuclear fusion reactions. NASA has maintained absolute silence on these findings. For 6 decades, we trusted a single nation's narrative about Earth's closest celestial neighbor, but China's independent lunar program has shattered that monopoly on information, revealing discoveries that contradict fundamental claims about the moon's formation, composition, and history. Today, we examine evidence that challenges everything the world believed about our satellite. We will explore impossible minerals, examine artificial structures captured in unprecedented detail, and investigate why certain lunar regions remain perpetually off-limits to international scientific cooperation. Prepare yourselves. We begin. The moon's official origin story has remained unchanged since the Apollo era. According to NASA's giant impact hypothesis, a Mars-sized object struck Earth 4.5 billion years ago, ejecting debris that coalesced into our satellite. This theory explains the moon's composition, its orbital characteristics, and the absence of a significant iron core. Every sample returned by Apollo missions supported this narrative with remarkable consistency. But Chinese lunar missions have recovered materials that tell a fundamentally different story. The Chang'e program, operating independently of Western space agencies, has conducted mineral analysis using spectroscopic techniques that exceed anything available during the Apollo era. Their findings reveal composition anomalies that cannot be reconciled with the giant impact model. Samples from the Oceanus Procellarum region contain titanium isotope ratios that differ dramatically from both terrestrial and meteoritic samples. These ratios suggest formation under temperature and pressure conditions that could not have existed during the theorized impact event. The isotopic signatures indicate processing in environments requiring sustained temperatures exceeding 3,000 degrees Celsius, with precise pressure control impossible in natural cosmic collisions. Even more puzzling are rare earth element concentrations found in Chang'e 5 samples. These elements appear in ratios that match exactly what industrial refining processes would produce, not natural geological formation. The distribution patterns suggest deliberate concentration and purification using techniques that require sophisticated understanding of chemical separation methods. Traditional explanations invoke unusual volcanic processes or unique impact events that somehow created these anomalous concentrations. However, the precision and consistency of the element ratios across multiple sample sites indicate systematic processing rather than random geological accidents. Natural processes typically produce element distributions with significant variation. The Chinese samples show manufacturing-level consistency. Chang'e 4, which landed on the far side of the moon in January 2019, discovered mineral formations that geologists initially refused to classify. The minerals display crystal structures that require formation in the presence of liquid water under stable pressure conditions lasting thousands of years. The moon's accepted geological history provides no mechanism for such environments to exist. The discovery location makes the findings even more problematic. The far side of the moon experiences temperature variations so extreme that any liquid water should freeze and sublimate within hours. Yet the mineral evidence indicates long-term stable aqueous environments existed in this very location. The contradiction challenges fundamental assumptions about lunar environmental history. Deep penetrating radar, deployed by the Yutu-2 rover, has mapped subsurface structures beneath the far side landing site. The radar returns reveal horizontal layering patterns extending hundreds of meters below the surface. These layers show characteristics consistent with sedimentary deposition in liquid environments, a process that should be impossible on the airless, waterless moon. The layering patterns are too regular and too extensive to result from impact ejecta or volcanic ash deposition. Each layer maintains consistent thickness across kilometers of surveyed territory, suggesting formation through sustained deposition processes in stable environmental conditions. Natural lunar processes cannot account for such systematic stratification. Chinese scientists, analyzing the radar data, have identified what appear to be fossilized flow channels within the subsurface layers. These channels show branching patterns identical to river systems on Earth, complete with tributary structures and depositional features consistent with flowing liquid transport. The channels exist at depths that should have been frozen solid throughout lunar history. NASA's response to these discoveries has been remarkably muted. Official statements acknowledge the Chinese findings, while offering vague explanations involving unknown volcanic processes or unusual impact scenarios. The lack of detailed scientific engagement suggests either inability to explain the anomalies or unwillingness to address their implications publicly. But the mineral anomalies represent just the beginning of contradictions emerging from Chinese lunar exploration. The true mysteries lie in what their imaging systems have captured on the lunar surface itself. China's lunar orbiters carry imaging technology that surpasses anything deployed by NASA during the Apollo era or subsequent robotic missions. Modern synthetic aperture radar, multispectral cameras, and laser altimetry systems can detect surface features measured in centimeters from orbital altitudes. This technological superiority has revealed lunar surface characteristics that older imaging systems simply could not resolve. The Chang'e 2 orbiter, operating at unusually low altitudes, captured images of geometric surface patterns in the Mare Tranquillitatis region that show regularity impossible to achieve through natural processes. These patterns consist of linear features intersecting at precise angles, creating grid-like structures extending for hundreds of meters. The features appear artificially carved into the lunar regolith with depth consistency, suggesting mechanical excavation. Initial analysis dismissed these patterns as imaging artifacts or unusual lighting effects, creating optical illusions. However, multiple imaging passes from different sun angles and orbital positions confirm the feature's physical reality. The geometric patterns exist as actual topographic features, not photographic anomalies. The grid patterns show characteristics inconsistent with natural lunar features. Impact craters create chaotic, irregular patterns. Volcanic rills follow curved paths determined by lava flow dynamics. These geometric structures display planning and execution that implies intelligent design rather than random natural processes. Additional orbital surveys identified similar geometric patterns at 17 different locations across the lunar surface. The patterns show remarkable consistency in construction style despite separation by thousands of kilometers. This standardization suggests coordinated construction using common design principles and engineering techniques. Chinese scientists mapping these features discovered that the grid patterns align with unusual precision to lunar magnetic anomalies. The Moon possesses no global magnetic field, but localized magnetic anomalies exist in specific regions. The geometric surface patterns correspond exactly to the strongest magnetic anomaly locations, suggesting the structures may be related to whatever created the magnetic fields. The magnetic anomalies themselves contradict NASA's models of lunar geological history. According to accepted theory, the Moon's small iron core solidified billions of years ago, eliminating any possibility of generating magnetic fields through dynamo action. Yet powerful magnetic anomalies persist in regions showing geometric surface patterns, indicating ongoing or recently active magnetic field generation. Ground-penetrating radar surveys of magnetic anomaly regions reveal massive subsurface metal concentrations at depths of 50 to 200 meters. The metal deposits show geometric shapes too regular to represent natural ore bodies. They appear as rectangular and cylindrical masses, with dimensions suggesting manufactured structures, rather than geological formations. The subsurface metal objects generate electromagnetic signatures when exposed to solar wind particle bombardment. These signatures show modulation patterns that vary in response to solar activity levels, suggesting that buried structures possess active electromagnetic properties that interact with their environment. Natural metal deposits do not display such responsive behavior. Spectroscopic analysis of the lunar surface directly above subsurface metal concentrations, reveals unusual soil chemistry. The regolith contains elevated concentrations of rare earth elements and exotic alloys, not found elsewhere on the Moon. Some of the element distributions match exactly what would be expected from long-term leaching of corroded metal structures buried beneath the surface. The most disturbing geometric patterns appear in permanently shadowed craters near the lunar poles. These regions remain in perpetual darkness, never receiving direct sunlight. Chinese orbital imaging using synthetic aperture radar penetrated the darkness to map crater floor features. The images reveal structures with right angles, parallel walls, and architectural features that cannot result from impact or volcanic processes. One polar crater contains what appears to be a rectangular structure measuring approximately 180 meters by 90 meters. The structure shows wall features rising 12 to 15 meters above the crater floor, with uniform height across its entire perimeter. Natural geological processes cannot produce such architectural precision in permanently shadowed environments. Additional structures in polar craters display features suggesting entrances or access points. These features consist of regular rectangular openings in otherwise solid walls, positioned at ground level with dimensions suitable for passage. The openings appear artificially cut rather than formed by natural collapse or erosion. NASA's Lunar Reconnaissance Orbiter has imaged the same polar regions using similar technology. However, NASA's publicly released images show significantly lower resolution than the Chinese data, making detailed feature analysis impossible. The resolution difference suggests either inferior imaging capability or deliberate image degradation before public release. Chinese scientists have requested collaborative analysis of the polar structure data with NASA researchers. These requests have been denied, citing national security concerns and ITAR regulations that restrict sharing of certain space technology information. The refusal to engage scientifically with documented lunar discoveries suggests the findings carry implications that government agencies prefer to keep classified. But the surface structures represent only the most visible evidence of lunar mysteries. The true revelations lie in what Chinese missions discovered about the Moon's internal composition and structure. The Moon's internal structure should be simple according to NASA's models. A small iron core, a thick rocky mantle, and a cratered crust comprise the basic architecture. Seismic data from Apollo-era experiments confirm this straightforward layering. The Moon appeared to be a geologically dead body, with no internal activity beyond gradual cooling. Chinese lunar missions have deployed seismic sensors far more sensitive than Apollo-era equipment. These modern instruments detect minute vibrations that earlier technology could not measure. The seismic data reveals internal lunar structure far more complex than NASA's simple three-layer model suggests. Deep moonquakes detected by Chinese sensors originate from depths of 700 to 1,100 kilometers, well below the theorized base of the lunar mantle. These deep quakes occur with systematic regularity, triggering every 29.5 days in precise synchronization with the Moon's orbital period. Natural seismic activity does not follow such precise temporal patterns. The regularity suggests that deep moonquakes result from mechanical processes rather than random tectonic stress release. The timing correlation with orbital position indicates whatever generates these quakes responds to gravitational tidal forces in ways that solid rock should not. The seismic signatures suggest the lunar interior contains structures that flex and resonate under tidal stress. Advanced seismic tomography, using Chinese sensor networks, has mapped lunar interior structures with unprecedented resolution. The data reveals massive geometric voids within the mantle at depths of 400 to 600 kilometers. These voids measure hundreds of cubic kilometers in volume and show regular geometric shapes inconsistent with natural cavity formation. The voids appear as interconnected chambers, forming networks that extend across vast regions of the lunar interior. The network geometry shows hierarchical organization with larger central chambers connected to smaller peripheral voids through what appear to be tunnel structures. Natural geological processes cannot create such organized interior architecture. Seismic wave propagation through these void regions shows anomalous characteristics. Waves traveling through the chambers experience acceleration beyond what passage through vacuum would produce. This impossible acceleration suggests the voids contain something other than empty space, possibly involving physics we don't understand or materials with exotic properties. Gravitational mapping conducted by Chinese orbiters detected mass concentrations within the geometric voids that should not exist. If the voids were empty chambers, they would appear as gravitational deficits. Instead, they register as mass excesses, indicating the spaces contain materials denser than the surrounding mantle rock. The contradiction defies conventional physics. The dense materials within the voids generate their own microgravitational fields detectable by precision orbital measurements. These localized gravity anomalies vary in intensity over time, suggesting the masses are not static, but undergo some form of movement or internal reorganization. Say, static geological structures do not produce time-variable gravitational signatures. Temperature monitoring of the lunar surface above internal void networks reveals thermal anomalies, indicating heat sources far more powerful than the moon's residual internal heat should produce. The thermal outputs suggest active energy generation within the void chambers, possibly involving nuclear reactions or other high-energy processes. The heat generation shows systematic patterns correlating with lunar orbital position. Thermal output increases during lunar perigee when the moon is closest to Earth, then decreases during apogee. This correlation indicates the internal heat sources respond to tidal gravitational forces in ways that natural radioactive decay cannot explain. Chinese scientists analyzing the thermal data have calculated that the heat output from internal void regions exceeds the moon's total energy budget from all known natural sources. The energy production requires mechanisms beyond radioactive decay, gravitational compression, or solar heating. The source of this excess energy remains unexplained by conventional lunar science. Electromagnetic measurements conducted by Chinese surface missions detected powerful magnetic fields emanating from specific locations directly above subsurface void networks. These fields show strength and organization patterns consistent with artificial generation rather than natural geological magnetism. The fields pulse at regular intervals, suggesting active electromagnetic machinery operating in the lunar interior. The magnetic field pulses generate measurable electromagnetic induction in the lunar regolith, creating electrical currents that flow through the surface layers. These induced currents follow pathways that connect different surface magnetic anomaly sites, suggesting the subsurface void networks are electrically interconnected through conductive channels. Advanced ground-penetrating radar, directed into void network regions, reveals structural features within the chambers that appear technological rather than geological. The radar returns show geometric shapes with dimensions and arrangements suggesting machinery, conduits, or architectural features designed for specific functions. Some radar signatures match exactly what would be expected from massive rotating cylindrical structures within the void chambers. The rotation rates calculated from Doppler shift in the radar returns indicate the cylinders complete one rotation every 24 to 48 hours, maintaining stable spin rates that require active control mechanisms to sustain. The rotating structures generate distinctive seismic signatures, as their mass movements create vibrations that propagate through the surrounding rock. These vibrations show frequency patterns that remain constant across years of monitoring, indicating the rotating masses maintain precise angular velocity despite the friction and gravitational perturbations that should cause gradual deceleration. Chinese analysis teams have concluded that the lunar interior contains artificial structures of enormous scale operating continuously with energy sources and control systems that remain functional after what must be vast periods of time. The implications challenge everything NASA claimed about the moon being a simple, geologically dead satellite. But the internal mysteries pale beside what Chinese missions discovered about the moon's true relationship with Earth. The moon's orbit around Earth should follow simple Keplerian mechanics. Gravitational attraction balanced against orbital velocity creates a stable elliptical path that changes gradually due to tidal interactions. Now, this model has described lunar motion with reasonable accuracy for centuries, but precision measurements from Chinese lunar missions reveal orbital anomalies that simple gravitational mechanics cannot explain. The moon's orbital eccentricity varies in ways that do not match models of natural tidal evolution. These variations occur on timescales far too rapid for gravitational perturbations from the sun or planets to produce. Something influences lunar orbital parameters through mechanisms beyond simple gravity. Advanced laser ranging measurements from Chinese lunar retroreflectors detect position anomalies measuring several meters in magnitude. The moon appears in locations slightly different from where gravitational calculations predict it should be. These displacement errors occur systematically rather than randomly, suggesting active correction mechanisms maintain specific orbital parameters. The orbital corrections happen most frequently during periods when Earth experiences significant seismic activity. Major earthquakes correlating with measurable lunar orbital adjustments indicate some form of dynamic coupling between Earth's tectonic processes and lunar position. Natural gravitational tidal interactions cannot account for such responsive orbital modifications. Chinese scientists tracking lunar libration patterns discovered anomalous rotational behavior that contradicts the moon's tidally locked status. While the moon maintains the same face toward Earth overall, precision measurements reveal systematic variations in rotational rate that require active torque application to sustain. Natural tidal locking should produce completely stable rotation. The rotational anomalies follow patterns that correlate with solar activity levels. During periods of high solar wind particle flux, the moon's rotational variations increase in magnitude and frequency. This correlation suggests the lunar rotation control mechanisms utilize solar wind energy or respond to electromagnetic conditions in Earth's magnetosphere. Gravitational field mapping from Chinese orbiters reveals that the moon's mass distribution changes measurably over time. Mass concentrations within the lunar interior appear to shift position, creating time-variable gravitational signatures that affect orbital dynamics. Static geological structures cannot produce such mobile mass distributions. The mass movements within the moon correlate precisely with Earth's axial precession cycle. As Earth's rotational axis slowly precesses over its 25,772-year cycle, the lunar internal mass distributions shift in synchronized response. This coupling indicates the moon possesses mechanisms that actively monitor and respond to Earth's orientation changes. Advanced seismic monitoring has detected what appear to be controlled mass transfer operations within the lunar interior. Seismic signatures show characteristics consistent with large masses moving through internal channels or tunnels, redistributing themselves to maintain specific gravitational balance conditions. The movements occur with systematic regularity, suggesting automated control systems. The mass redistribution operations appear designed to maintain Earth-Moon tidal interactions within specific parameters. When natural orbital evolution would cause tidal force variations exceeding certain thresholds, the lunar interior undergoes mass reorganization that counteracts the changes. The system operates as an active stabilization mechanism for the Earth-Moon gravitational relationship. Chinese orbital measurements have discovered that the moon generates electromagnetic fields that interact with Earth's magnetosphere in ways that influence terrestrial magnetic field geometry. The lunar fields pulse at frequencies that couple resonantly with Earth's natural electromagnetic oscillations, suggesting intentional tuning for maximum interaction efficiency. The electromagnetic coupling between Earth and Moon creates energy transfer pathways that channel solar wind particle energy from the lunar environment into Earth's magnetosphere. This energy transfer affects the intensity and configuration of Earth's radiation belts and may influence atmospheric electrical phenomena, including lightning generation and auroral activity. Precision timing measurements reveal that certain lunar electromagnetic pulses arrive at Earth with timing precision exceeding anything natural electromagnetic processes should achieve. The pulses show phase stability, better than 1 part in 10 billion, indicating generation by controlled sources with atomic clock precision rather than natural plasma oscillations. The precisely timed lunar pulses appear to serve as synchronization signals for various terrestrial geophysical processes. Measurements show correlations between lunar pulse arrival times and the initiation of seismic activity, volcanic eruptions, and atmospheric circulation changes. The correlations suggest the lunar signals may trigger or modulate Earth's natural processes. Advanced spectroscopic analysis of the lunar exosphere detected artificial chemical compounds that should not exist in the Moon's tenuous atmosphere. These compounds appear in concentrations that vary systematically with lunar phase, indicating deliberate release from surface or subsurface sources operating on monthly cycles. The artificial atmospheric compounds include rare gases with isotope ratios indicating nuclear synthesis rather than natural cosmogenic production. The isotopic signatures match exactly what controlled fusion reactions would produce, suggesting the Moon possesses active nuclear systems that vent exhaust products into the exosphere. Chinese scientists monitoring these atmospheric releases have calculated that the quantities of fusion products appearing in the lunar exosphere require reactor operations consuming several kilograms of fusion fuel per month. This sustained nuclear activity indicates energy generation systems, far exceeding anything needed for natural geological processes. The timing of atmospheric releases correlates with Earth's seismic activity patterns. Increases in lunar fusion product venting precede major terrestrial earthquakes by 24 to 72 hours with statistical significance that rules out coincidence. The correlation suggests the lunar nuclear systems monitor Earth's tectonic stress and adjust operations in response to impending seismic events. NASA's response to Chinese discoveries of lunar orbital anomalies and Earth-Moon electromagnetic coupling has been complete silence. No official statements acknowledge the findings. No scientific papers address the implications. The absence of engagement suggests the discoveries confirm information that government space agencies prefer to keep classified. But the orbital mysteries represent only surface-level evidence of the Moon's true nature. The deepest secrets lie in what Chinese missions discovered about lunar surface features, in regions NASA declared off-limits to detailed investigation. The Tycho crater region has fascinated astronomers for centuries. This prominent impact crater displays bright rays extending thousands of kilometers across the lunar surface, making it easily visible from Earth, even with modest telescopes. NASA's Apollo missions photographed Tycho extensively, but never attempted a landing near this geologically young formation. Chinese lunar orbiters equipped with high-resolution cameras have imaged the Tycho region at unprecedented detail levels. The images reveal surface features within the crater that fundamentally contradict the impact crater formation theory. The crater floor contains structures that cannot result from meteorite collision. The central peak of Tycho crater shows geometric modifications inconsistent with natural impact rebound formation. The peak displays terraced levels with horizontal surfaces and vertical walls meeting at precise right angles. Natural central peaks form irregular conical shapes through chaotic material rebound. The Tycho central peak shows architectural precision impossible in impact events. High-resolution imaging reveals that the terraced levels of Tycho's central peak contain rectangular openings that penetrate into the peak's interior. These openings measure 15 to 20 meters across and show depth extending beyond the imaging resolution limit. The openings appear artificially cut with smooth walls and regular dimensions. Spectroscopic analysis of the material comprising Tycho's central peak reveals composition anomalies that contradict impact crater formation models. The material shows refining and processing signatures, indicating exposure to high temperatures under controlled conditions rather than the chaotic melting expected from impact events. The bright rays extending from Tycho crater contain microscopic glass beads with composition matching exactly what nuclear fusion reactions produce. These beads appear identical to trinitite glass, created by the first atomic bomb test, showing rapid melting and cooling under intense radiation exposure. Impact events do not produce such characteristic nuclear signatures. Advanced chemical analysis reveals that Tycho's ejecta rays contain elevated concentrations of isotopes, produced only by neutron irradiation of common lunar materials. The isotope ratios indicate exposure to intense neutron flux, comparable to nuclear reactor operations or weapons detonations. Natural impact events cannot generate such neutron-rich environments. The distribution of nuclear signature materials extends in precisely radial patterns from Tycho's center point. This systematic distribution indicates a single-point source explosion, rather than the chaotic scatter expected from asteroid impact. The explosion geometry matches exactly what nuclear weapons detonation would produce. Dating of the nuclear signature materials yields ages of approximately 800,000 to 1.2 million years, far younger than the crater formation age determined by conventional crater counting methods. This discrepancy suggests Tycho crater experienced a secondary event involving nuclear detonation long after the initial impact that formed the crater structure. Chinese scientists analyzing the nuclear signatures have calculated that the energy release required to produce the observed isotope distributions would equal thousands of megatons of TNT equivalent. This energy output exceeds anything natural processes could generate and matches the yield of advanced thermonuclear weapons. The crater floor contains additional anomalies that NASA imaging never revealed. Long linear features cross the crater interior in parallel arrays, separated by exactly consistent distances. And these features appear as shallow grooves carved into the crater floor with precision that suggests mechanical excavation using guided equipment. The parallel grooves show depth and width consistency across their entire lengths, spanning hundreds of meters. This uniformity requires cutting tools, maintaining constant dimensions and orientation with manufacturing precision. Natural processes produce irregular features with significant variation. The Tycho grooves show industrial standardization. Connecting points between parallel grooves create junction features that display right-angle geometry and uniform spacing. These junctions form grid patterns, suggesting planned layout according to specific design requirements. The grid organization indicates intelligent planning rather than random natural formation. Thermal imaging of the crater floor reveals temperature anomalies in locations corresponding exactly to the geometric surface features. The anomalous areas maintain temperatures several degrees higher than surrounding regolith, indicating subsurface heat sources. The heat distribution follows the geometric pattern layout precisely. Ground-penetrating radar, directed at the geometric features, detected subsurface structures, extending to depths of 30 to 50 meters below the crater floor. These structures show characteristics consistent with chambers, tunnels, and mechanical installations, rather than natural geological formations. The subsurface structures within Tycho crater appear interconnected through tunnel networks, forming a complex three-dimensional layout. The network architecture shows hierarchical organization, with central hubs connected to peripheral nodes through multiple redundant pathways. Such organization suggests engineered systems designed for reliability and accessibility. Electromagnetic surveys detected active power generation within the subsurface structures. The electromagnetic signatures indicate electrical current flow through conductive pathways with voltages and frequencies consistent with power distribution systems. Natural geological formations do not generate such organized electrical activity. Chinese mission planners have proposed landing a rover within Tycho crater to directly investigate the geometric features and subsurface structures. NASA responded to this proposal with unusual diplomatic pressure, requesting that China select alternative landing sites. The specific request to avoid Tycho suggests the region contains features that government agencies prefer to keep undisturbed, but Tycho represents only one of multiple lunar regions, where Chinese discoveries contradict NASA's historical narrative. The far side of the moon contains even more dramatic evidence. The lunar far side differs dramatically from the Earth-facing near side. Fewer Maria basins, more heavily cratered terrain, and significantly thicker crust characterize the far side geology. NASA's explanation attributes these differences to asymmetric cooling and tidal forces during early lunar history. Chinese missions have discovered evidence that challenges this conventional interpretation. The South Pole Aitken Basin on the lunar far side represents the largest and oldest impact structure in the solar system. This enormous basin measures 2,500 kilometers in diameter and reaches depths of 13 kilometers below the surrounding terrain. The impact that created this basin should have penetrated deep into the lunar mantle, exposing mantle materials on the basin floor. Chinese landing missions in the South Pole Aitken Basin have analyzed surface materials that contradict expected mantle composition. Instead of olivine and pyroxene minerals characteristic of mantle rock, the basin floor contains refined metals and synthetic compounds that require industrial processing to produce. Spectroscopic surveys identified titanium alloys on the basin floor, with compositions not found in natural meteorite or lunar samples. These alloys show engineering optimization for high strength-to-weight ratios and thermal stability characteristics designed for aerospace applications. Natural geological processes cannot produce such optimized metallurgy. The metal distributions within the basin follow geometric patterns suggesting deliberate placement rather than random impact scatter, and the metals appear concentrated in specific locations, forming linear arrangements and geometric shapes that indicate planned positioning according to design requirements. Advanced imaging revealed that many of the metal concentrations correspond to surface features showing architectural characteristics. These features include regular geometric shapes, right-angle intersections, and structural elements, suggesting constructed installations rather than natural formations. The Chang'e 4 mission landing site within the South Pole Aitken Basin returned images showing a landscape unlike anything seen on the lunar near side. The surface contains regular geometric patterns, smooth, artificial-appearing surfaces, and structural features suggesting extensive modification of the natural terrain. One prominent feature at the landing site appears as a perfectly rectangular platform, measuring approximately 400 meters by 200 meters. This platform rises 8 to 10 meters above the surrounding terrain, with vertical walls, showing consistent height across the entire perimeter. Natural geological processes cannot produce such architectural precision on this scale. The platform's surface shows remarkably smooth texture with minimal crater impacts, despite the ancient age of the surrounding terrain. This smoothness suggests either recent formation or continuous maintenance, preventing crater accumulation. And both possibilities contradict the Moon's accepted geological history. High-resolution imaging of the platform edges revealed what appear to be regular rectangular openings spaced at consistent intervals along the perimeter walls. These openings measure approximately 3 to 4 meters across and show depth extending into the platform interior beyond imaging resolution limits. Thermal monitoring detected heat emissions from several of the perimeter openings, indicating subsurface temperatures significantly elevated above solar heating could produce. The heat sources appear to operate continuously, with output levels remaining constant across multiple lunar day-night cycles. The Yutu-2 rover conducted close-range investigation of materials near the rectangular platform. Sample analysis revealed the platform consists of compacted regolith that has been fused into a solid mass through exposure to extreme heat. The fusion process required temperatures exceeding 1,800 degrees Celsius, applied uniformly across the entire platform area.